Yeah, good morning again. I personally have a long interest of what is the interrelationship between different resource systems. So this example is energy, water, land, and livelihood. This is a work that has been published in January this March. It's very much related to a Kusum scheme that recently has been rolled out by the Ministry of Power. The exploration is the following. So how can an intervention in the energy sector have positive synergies and results when we talk about water, land, and livelihood in the agricultural sector of Tamil Nadu? So there's a lot of issues and challenges related when we talk about agriculture. Coming from the electricity side, agriculture accounts for about 20% of the electricity supply in the state. And you are well aware that agricultural supply is free of cost for the farmer. It is subsidized by the state government. So the Tancheku receives about 2,850 rupees per HP per year from the finance department, and the rest is cross-subsidized by Tancheku itself. So 20% electricity consumption. We have 80% of the water consumption that goes on account of agriculture. So recently, when you were following the media, we were close to net zero day in Chennai, where Chennai is running out of water. There was very little dialogue about who accounts for the water consumption, what percentage, and what are possible solutions about it. So agriculture was not talked about at all. And 80% is a huge amount. Also, if you compare the water use efficiency of India's agricultural system with comparable countries like Brazil or China, the cubic liter of water per ton of agricultural produce in India is extremely high. So we talk about water consumption. So then we have, Tancheco has about 21 lakhs of agricultural pumps connected to their grid. And those 21 lakhs account for about 8.8 megawatt of connected load, which is about a third of the entire capacity, load capacity of the state. So that's a huge amount. And of course, we have the agrarian distress. I think in the year 2016-17, we had 365 farmers committing suicide in Tamil Nadu. And that was the lowest number in years. We have the water shortage, and I mentioned we have a very low per capita or per household income for the agricultural sector. As per Niti Aayog, an average farm household in India has an annual income of 1.2 lakhs. So the exploration was of how can an intervention in the energy sector have possibly positive effects on water consumption, livelihood for the farmer, and productivity of the land and the crop. So what happens today, if you have traveled in rural Tamil Nadu, you may have seen when you go to a farmer, the pump is always switched on. The farmer doesn't know when power supply comes. So typically they would have 4, maybe 8 hours of power during the day. It may come in the morning, it may come at night. So since the farmer doesn't know when power comes, the pump is always switched on. So irrigation happens not when water is required, but when electricity supply, three-phase electricity supply is there, which means fields are over-irrigated. So if you over-irrigate fields, A, your groundwater level reduces, B, your soil nutrients are being washed out, and you use the fertility of the soil, which again in turn results into less yield and less income for the farmer. So let's look at the following. This is, on the left hand, this is what we have today. This is supply to agriculture, and this is supply to any other consumer category, domestic, industrial, commercial. The average cost of supply for Tancheco as of today per kilowatt hour is about 8.04 rupees. That's what it costs to deliver the kilowatt hour to your doorstep. We have talked a lot about distributed generation and the benefits of distributed generation. So if I have a behind the meter system, I have no transmission or distribution losses, for example. So if I were to put a grid connected solar behind the service connection of the farm, instead of having a cost of supply of 8.04, I could bring it down to a cost of supply of 4.6 rupees per kilowatt hour, which is a saving of about 42%. The farmer may not consume all the solar produced from the farm, so there will be something exported to the grid. This the utility could sell to another consumer category. So again, instead of cost of supply of 8.04, including distribution losses and overheads, it would cost the utility 6.46. So this is a saving of 19%. 8.04 as compared to 6.46. So that's the basic starting point where I want to take you along with. Now this is for 1 year, right? So we could assume that if you look at a 20 or 25-year horizon, that the grid power, the cost of grid supply will increase at least by the cost of inflation, 5%. So if we say today we are at 8.04, we increase it by 5% over 20 years. In 20 years, the cost per kilowatt hour would be close to 20 rupees. So the advantage of solar is that the cost is stable over a 20-year time period because it's a one-time capital investment. So the cost of solar will be the same over the next 20 years, right? It is always 4.6 rupees in this case. Now, the delta between the red line and the yellow line is the cost savings over a 20-year time period, which is substantial. So we have been exploring of how can we make sense out of Kusum and what would be a sensible approach, looking again at all stakeholders. What is in for the farmer? How can we look at water conservation? How can we take the utility along? Yeah, thanks, Vishnu. So is everybody aware of what Kusum is? So just shortly, Kusum is a scheme that has been, or the guidelines has been recently announced by the Ministry of Power. It aims at introducing either grid-connected or off-grid solar system for agriculture, and it is promoted as a pro-farmer scheme at the moment. But if you were to look closer, you could question those components. So now this is how it could look. So if you look at the Kusum guidelines, they expect the farmer to do investment into the solar system. So it's very unlikely in the context of having free electricity supply that the farmer would invest into a solar system. So we thought it wouldn't work. Now, alternatively, the investment could come from a third party. And the third party gets paid on the gross production of solar by the utility. So then what's in for the farmer? In order to make it attractive for the farmer, we thought there could be a farmer incentive where the farmer gets compensated to allow the installation of solar panels on the farm and to reintroduce the metering. Not only this, but we talked about demand side management today. The farmer incentive could be designed that it incentivizes the farmer to reduce electricity consumption and to maximize export. So how can you reduce electricity consumption? First one is by conserving water, because every liter of water that doesn't need to be pumped reduces electricity consumption. And the second one is by introducing efficient pumps. So roughly how this scheme would look. You have a developer that installs the system behind the meter at the farm. The developer supplies the power to the Dancheco grid. Dancheco pays the developer for every kilowatt hour produced. In this case, we have assumed 4.6 rupees per kilowatt hour, which is actually without the 60% subsidy that is coming under Kusum. So under Kusum, this amount will be much lower. Now the farmer continues to get free electricity supply from Dancheco. And the farmer will get an incentive which could be designed as the following, which is surplus export from solar multiplied by a virtual credit minus import from the grid multiplied by a virtual credit factor. Now I want you to look at a virtual farm. So this is a 5-acre banana farm. with a 7.5 HP pump. Yeah. So today there is no solar production. This farm consumes about 7,332 kilowatt hours per year for pumping. The cost of energy supply to the utility, to this Tancheko, is 58,950 rupees per annum. And the income of the farm today is about 5 lakhs on 5 acres. Yeah? So this is a virtual farm. So this is what happens today. The two bar charts on the left is for 1 year. Yeah? And the 3 here at the bottom is over a 20-time horizon. So as mentioned today, it consumes 7,332 kilowatt hour of electricity. It costs the utility a 58,000 for supply. There is no savings to Dancheco, there is no water savings, and there is no farmer income. And we're only looking at the yellow bars. Yeah? So I'll take you along. So now let's introduce a grid-connected solar system. We assume the farmer consumes 50% of the electricity from solar, the rest is exported. The consumption is the same. There's no reduction in consumption for the pump. However, the cost of supply in year 1 goes down from 58,000 to 30,000. Over 20 years, it's a saving to Dancheco of 86%. There's no water savings, but there is a little income increase to the farmer of less than 1% on account of the farmer incentive that I've mentioned earlier. Yeah, so step 1. Now, talking about energy efficiency, now let's introduce an efficient pump. Assuming we save 35% of electricity, you see the cost of supply or the consumption goes down from a 7,300 to a 5,132. Cost of supply decreases further. Now we are only at 18,000. So remember, we started at 58,000. So a huge reduction. Over 20 years, you see, Dancheco actually would make a profit, a saving of 108%. So the first time that you would make a profit of free electricity supply to agriculture. There is no water savings yet. There is a slight increase in income to the farmer. Can you guess why? As compared to grid-connected solar only? Because the farmer incentive has been designed that if he reduces his electricity consumption, his income from solar increases. Yeah. All right, one more step. Now we introduce what I call advanced irrigation, which is basically micro irrigation that can be remotely controlled, switched on and off. Assuming a 45% water saving, and water saving translates 1-to-1 into electricity saving. So look at the first one. We started with 7,332. Now we are down to a 4,000. Energy consumption. Cost of supply is down to a 12,000 per year in the first year. Overall, we have 119% savings to the utility, a 45% water savings, and an increase in farmer income of 65.9. And why 65.9? Because typically precision irrigation increases the yield for the farmer substantially. So this is something that works for everybody. The farmer has a substantial income increase. We look into water conservation and can substantially reduce the water consumption. The utility would have a substantial gain. It's also that typically small-scale solar systems produce more jobs than utility-scale solar systems. So it's another good reason to promote distributed generation. On an average, it produces about 3 to 4 times more jobs than the bigger systems. So if I'm concerned about job creation, water and farmer income, that would be an attractive approach to take. Now I thought, what are some questions that the media could ask? And that was something that Vishnu has asked me to prepare. So I thought about the following. How do we address energy, water and food security while creating jobs at the same time? Or how can Kusum be designed and implemented that it's a win-win for everybody, including the farmer. And finally, how do we find solutions for the discoms revenue loss due to subsidized or free electricity to the agricultural consumers and to other consumer categories? And I leave it there, and I'm open for questions at the discussion round.
But it's pretty much paddy that they cultivate, and paddy is a water intensive crop. There are alternatives for that, but farmers predominantly are not willing to switch over to the alternative due to a lot of factors. So in such a situation, how do you recommend we switch to, say, the one you showed, or how do you recommend we do it a more energy efficient model?
Please correct me, I think under the irrigated land in Tamil Nadu, paddy accounts for maybe 20%. So now, of course, when I talk about micro irrigation does not work for paddy. It works for horticultural crops and any kind of orchard. But that's still a huge amount. So then for paddy, you would have to continue with flood irrigation, or you ask yourself the question, which is a more fundamental question: do I grow paddy in areas that are under water stress? Or do I grow paddy in areas like in Orissa where I have an abundance of water? Because we also tend to grow crops in areas where we actually shouldn't grow them, including sugarcane. Did you hear her question? So I agree with her and I have no answer. She was asking, so how do you incentivize farmers that they would switch maybe to crops that are more suited for the local agricultural conditions to grow? And maybe not paddy when you're in a drought area. I don't know. Because, I could give you an answer, but it's a very delicate one because we have also MRPs. And is it the right instrument, for example?
So, excuse me if I'm repeating the question, but I think when we started with the PRISM scheme, your presentation, the general operating philosophy has been the power comes when the power comes, right? And if you look at all these things for the grid-connected solar to work, the power needs to be on. Is there going to be a conceptual change in thought for TANGEDCO to now leave the three-phase supply on, so that they can get the benefit, or is it still going to be stranded investment of solar PV now, in addition to?
In the case of Tamil Nadu and as of today, it looks like the tether will invest into the solar systems. And I was part of a consortium that has been consulting with TED and TANGEDCO over the last 12 months to design the scheme. So as of today, because Germans keep on changing, and philosophy and culture keeps on changing within TANGEDCO, TANGEDCO is quite excited about this one because they see it as an opportunity for them to alleviate the stress of supplying free electricity to agriculture. So whether eventually the feeders will be on 24/7, I don't think so, but as long as they are on during sunshine hours, it is a good start.
Is it likely that there will be a pilot to show that this actually works, whatever you have showed on paper actually works on site?
Yeah, I have been pilots, not necessarily in Tamil Nadu, but in other states like in Gujarat. And there's not much to show from the technical point of view that it works. I think the question is the financial design and the social approach to the farmers. How do you get a buy-in from the farmers to participate in that way? So I asked, for example, can we do pilots? And for them, 10,000 is a pilot. 10,000 farms is a pilot. Because we are talking about 21 lakh. I wanted to do 5 pilots.
Wouldn't off-grid work better for agriculture?
Would off-grid work better? There's a lot of different philosophies even about off-grid and on-grid. You see, if today I have a grid connection, why would I surrender my grid connection and then go for an off-grid solar system where typically I would not harvest the entire energy because I only use the energy when I pump, right? When I don't pump, the potential electricity is being not used, not utilized. So if there's a grid connection, my recommendation is, for God's sake, connect it to the grid.